So early on in the workshop, I'm going to expect us to do some wiring diagrams to help us with a one-way lighting circuit. How many times have we walked into a room, operated the light switch, and the light has come on in from one position? So that's what we're going to do here. We've got one light switch controlling one light. We've got a picture now down here of a consumer unit. We've got a ceiling rose and pendant. So we've got one of these, ceiling rose and pendant. And we've got a one-way switch here. So we've got a light switch here. However, the connections, even though this is a wiring diagram, won't be exactly the same in the consumer unit when we wire it up. Got to be very careful to select the appropriate terminations for those. But the connections in the ceiling rose or batten lamp holder and the one-way light switch will be identical from this drawing as it will be when we get into the workshop. For this drawing, we're going to use PVC, PVC twin and CPC cables for all the cable runs. So we're going to have a brown one, a blue one and a green and yellow. And at the moment, we know that we need to add the green and yellow sleeve in order that we can identify our circuit protective conductor. The brown one we're so used to calling our line conductor, the blue one's our neutral and obviously our CPC. But in this drawing we might find that now the blue one is going to be identified differently and called a different conductor as well. But let's first of all concentrate on the cable from the consumer unit to the actual light fitting itself. The light fitting itself has several blocks in here and these are separated from each other. So there's a block of 2, a block of 3 and a block of 3 here. They're insulated from each other. So this block of 2 is not connected to the block of 3 and this block of 3 in the center is not connected to this block of 3 here. So let's have a look at that in here. So what we've got is, we've got a block of 2, so that's a brass block with 2 terminating holes in it. A block of 3, which is our loop terminal. Got 3 holes in it, and again, it doesn't matter which ones we go in when we use the loop, but we've got a block of 3, and then we've got a block here of 3, which is neutral. And again, it doesn't matter which ones we go in. We see already in this case, we've got a brown one, which is a switching line to go to the actual lamp holder itself, and a blue connection for our neutral to go to our lamp holder itself. If we look at a ceiling rose and pendant, we've got exactly the same scenario going on. You've got a block of 2, which is our switching line, with a brown one going to the actual lamp holder itself. You've got a block of 3, which is our loop, and a block of 3, which is our neutral, with one of those going to the actual lamp itself. Exactly the same here. 2, 3, 3. Switching line, loop, neutral. And it's how we use those in order to make the connections for this lighting circuit. I'm going to start by doing the cable that comes from the consumer unit to the light itself. And we're going to be using this one here. We're going to be using it in the workshop, 1mm squared PVC, PVC, twin and CPC cable. On-site lighting circuits can often be wired in domestic dwellings using 1.5mm squared cable. We're going to talk through the connections as we go. Let's start off with the line connection in the consumer unit, which is going to come out of here. This is the symbol for a fuse and is often shown in exams in multi-choice conditions. What is this symbol? That's the symbol for a fuse. This one here is a symbol for a neutral link, and this is our earth bar where our CPCs will be connected. When you do your drawings for me, you're going to not be doing them freehand. People will be shouting at me, Gaz, you're doing them freehand. I am doing them freehand, but we'd expect us to use a ruler and line up appropriately. So this cable here, which is the permanent line connection, is going to come into the center here. It's not going to come into these outside 2. These outside 2, as we saw here, had these flexible cables on them, and we had a brown one that came out to the light fitting, and we also had a blue one that came out to the light fitting as well. This brown conductor coming from the actual consumer unit will bring a permanent line connection in. If I connected it to this side of the lamp and a neutral to this one, the permanent line will pass through the lamp and through the neutral and illuminate all the time. We want to gain control from the switch below. So this is where this center terminal of 3 called the loop comes in. Doesn't matter which one of the 3 holes we use, but I am going to use this one just here. Okay, and I'm going to bring those 2 together. Now you're going to do this way better than me in order that you can line these up. Okay, so my line cable comes in and is connected into the center loop terminal. Any of the 3, I've chose the first one. That's the permanent line coming in. As it's a twin and CPC cable coming from there, we can look at the neutral next. Neutral comes out of this, in our case, neutral link. I'm going to find out where that goes. This block here marked with an N of 3, of which one's already got a blue cable going off to the light fitting, is our neutral. So if I just drop that down to there, and I'll bring the 2 together, like so. So my neutral comes from my consumer unit, from the neutral bar, not from the symbol here. There'll be a neutral bar within your consumer unit. It comes up and is connected to this side of the lamp. you can now see if we'd have put this one this side, our lamp would have illuminated, and at this stage it won't because we've put that into the loop terminal. We need a CPC. I'm very happy in the classroom that we use just green, but some people like to use green and put a striking yellow down the side. So let's bring a green up, and we're going to connect it into our actual earth terminal just there. So let's look at where that is in the actual batten lamp holder. Batten lamp holder there is our earthing terminal. It doesn't need a CPC in here, believe it or not, because it is fully insulated, it's fully plastic. But we know these fittings can be changed in the future for metallic ones, and a metallic light fitting is an exposed conductive part, and the metal work needs connecting to the CPCs that will be left in here. So that's our CPC terminal. It's only got one in it. This one's slightly different. It's got a brass block with 2 holes in it, and again, it doesn't matter which one you put your CPCs in or out, but there's 2 terminating points for that in this one. We've only got one on our drawing. Some people, as I said, do like to just put a strike down the side of it of yellow. It still only makes it 1 cable, but it's trying to identify that as a CPC. So in other words, we've got the following, haven't we? We've got our CPC identified as green and yellow throughout its run. So it's just the 1 cable, PVC, PVC twin and CPC from our consumer unit into our light fitting. The permanent line comes in and goes into loop. The neutral comes from our consumer unit, goes into neutral terminal, and our CPC comes in and goes into the earth terminal in the back of the light fitting itself. That's our first cable. We're now going to bring a cable down to the switch. So we're used to seeing our switches. This is a 1-gang switch. This is a 1-gang because it only has 1 switch on it. When we turn it over, we've got the following. We've got common and L1, sometimes shown that way round. So we've got common and L1. Doesn't matter which way round it goes. It just means that maybe when you turn it on, that would be off. You would need to turn it round in order to get the right way round. So if that's on and it actually was the on position, but the light fitting was off, obviously you'd just spin it round. So we've got common, we've got L1, and we're going to take those connections down there. This is also fully insulated, so there's no CPC terminal in here. But we will bring a CPC down because we know that this plastic light switch in the future could be changed for a metal one, and a metal light fitting is an exposed conductive part. For this drawing, I'm going to show you taking a twin and CPC cable down from the actual light down to the actual switch itself. Often in the workshop, then we use twin brown, but lots of colleges don't. So I'm just going to do this one where we use the same cable again. So at Tresham, we might be taking down a twin brown and CPC. But most colleges and most electrical installations don't. They actually use twin and CPC cable, but this now will not be a neutral. This blue conductor will actually be a switching line and needs to be identified accordingly. Let's put the cables in first, the conductors on our drawing, in order to see where they're going to go. So this cable comes down to our switch. We're going to come out the loop-in terminal. There's 2 holes to choose from. Doesn't matter which one we take, but I'm going to take that one down from the center one, and I'm going to take that straight into common. I'm going to take down a blue cable, which is going to come back from here, but this is not a neutral, so it won't be connecting in here. It's a switching line conductor, so it's going to turn this light fitting on. So I'm going to connect these 2 together with a blue cable, and then finally the CPC terminal here to the CPC terminal here, so the earth terminals are linked together. And again, I know people do like to put a strike of yellow down the side of that one as well. So it isn't a neutral. So the line comes down here, the permanent line comes down here, and at the moment the switch blade is open. When we close the switch, so when we turn the switch on, this now comes down and brings the line onto here, the blue conductor. This is now a switching line conductor. So it's not a neutral and needs to be identified as a switching line conductor. That means we put a little bit of brown sleeving onto the actual blue, which is not a neutral, in this case is a switching line conductor. In order to do that, we need to take a pen and just put a little square around it to identify that with what is brown sleeving. So there's some brown sleeving on here and here. So at both ends, both the switch and in the light fin itself, on site, you're going to often see a blue cable, which isn't neutral, which is identified with brown sleeving as a switching line conductor. And it's really important that we put those on because we don't want to start confusing this and putting it into the neutral connection itself. So let's go through those connections. Our permanent line comes from our consumer unit on top of the circuit breaker. So in other words, where we're used to screwing it on top of the circuit breaker, it comes and is connected into the loop-in terminal, the middle set of 3. Any hole, doesn't matter. We bring our neutral from our neutral bar in our consumer unit, and we bring our neutral into our terminal. Marked neutral, there's 3 to choose from. Doesn't matter which one we choose. And from our earth bar in our consumer unit, we bring our CPC into the terminal in the back of the light fitting, ready in case it's changed for an exposed conductive part. So that's our first twin and CPC cable that we bring in. We then take a twin and CPC cable down to the switch. We bring down the brown one, connect it in common as our permanent line connection. Our CPC into the back of the box gets fully insulated for us. And then this blue one, which is not a neutral, which is identified both ends with brown sleeving, as our switching line. And we can see that once we've got a neutral this side of the lamp and we close that switch, our line connection comes through here, down here, close the switch, comes down our switching line and onto our lamp, causing it to illuminate. So if the switching line is this side and the neutral is that side, we end up having a fully illuminated lamp. That would be our one-way lighting circuit, our basic first one-way lighting circuit. I'm going to ask you to extend this. So in other words, repeat the process. Say this is bedroom number 1, and we're going to do another repeat of this. So in other words, you're going to screw another ceiling rose and then have another switch, and they're going to be independently working. So in other words, in another bedroom. To do that, you've got to just move this cable effectively out of here and into the next room. So it might be that this cable came in from the consumer unit, but then the next one is going to go into the next room. So the next room will need the permanent line, a neutral and a CPC, and they will be gained from the loop-in terminal where the permanent line is, the neutral and the CPC. So let's take those out into the next room. The line cable comes out, goes into the next room. The neutral will come out and that will go into the next room. And then the CPC will come out and that will go into the next room. Let's put a little bit of yellow on that. So what's happened there is we've got this section here going to repeat itself when it enters the next ceiling rose. Neutral into the block of 3 in this room. The line, permanent line, into the loop-in terminal of the next fitting. The CPC into the earth terminal of the next fitting. And then we drop down to the next switch and repeat the process. So this here, I would like you to put this onto your drawings and say to the next room. Okay, so we'd say here to the next room in order that we can repeat the process. So what we've shown here is the wiring diagram using twin and CPC cables, in this case 1mm squared for us, in order to do the wiring diagram of a one-way lighting circuit. From the consumer unit to the light fitting, from the light fitting to the switch. And if you're lucky enough to extend your job, you'll take another cable out to a ceiling rose, down to a switch, and you'll keep repeating the process. As always, I hope this video has been some help.